Well, let's go back to my previous problem that I did, where we have two coordinates E and F, and I want to find the length or the distance between those 2 points. If I were to draw a right triangle connecting E and F, you'll notice that if I count the length of F, I get a length of 7. And that is the same as, and so this is the difference between my two x coordinate values, -1 and +6. I can call that B. And the difference between my y coordinates does equal 4, which I can write as y2 minus y1, or A. We know Pythagorean theorem, a squared plus b squared equals c squared. Well, what if I substitute A for my y values, my y2 minus y1, and I substitute B, x2 minus x1, and that all equals c squared. Now, if you remember, the last step to solving Pythagoras' theorem is always to take the square root. So if I was to take the square root of both sides, what I get is c is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. Now, other than the swapping of the x and the y, x and y coordinates, there is no difference between Pythagoras' theorem and the distance formula. So essentially, the distance formula is the equivalent of Pythagoras' theorem on the coordinate plane, where we substitute side A for the difference in my y coordinates, which we know is 2 minus a -2, which does give me 4, which is what I got when I counted on the graph. And x2 minus x1, the difference in my x coordinate is 6 minus a -1, which does equal 7, which is like what I got when I counted. So the only difference between the distance formula and Pythagoras' theorem is the distance formula is performed on the coordinate plane, whereas Pythagoras' theorem strictly works with right triangles, not on the coordinate plane. Pythagoras' theorem states that if I square the two legs of a right triangle, A and B, that those two squares, the sum of those two squares, is equal to the square of the hypotenuse C. Simply stated, a squared plus b squared equals c squared. Now, if I plug my a values for a and b into my equation, I get 4 squared plus 7 squared equals c squared. 4 squared, or 4 times 4 is 16. 7 squared is 49 equals c squared. And when I add 16 plus 49, I get 65 equals c squared. So 65, so that represents the area of the square And that's a very poorly drawn square, I apologize. Remember, square has all sides are the same. So c squared, or c times c, has an area of 65. Now, to determine what the length of just one side of the square is, we take the square root of 65, which is approximately 8.06 or 8.05. Okay, so that would be the length of the hypotenuse of this triangle. So the question is how does this relate back to the distance formula?